I lost the reference sheet that I was going to use to do this. Okay, so I'm going to just do it off memory right now, which is what I do. I had it all written down exactly how I wanted to do it before. And I'm just going to go straight off of memory right now. Okay, so the point of this sheet for you. Thank you. Yes. Okay, the point of this. I already look like a total loser sometimes in this class. So the point is for you guys to recognize when certain symbols are used and why, and then for you guys to have kind of a template as to how you're going to write about it. Okay? How you're going to write about numbers. So you know when this is over what numbers I need to write about and what I don't need to write about, what I need to include. Okay? So quantitative research methodologies. You remember from way back, what are the 3 types of quantitative research? Survey. One. The other one starts with an E.
Experimental.
Experimental. And there's another one that starts with a C. Correlational, correlative, whatever. Okay, so those are the 3. So let's talk about experimental research first. So in this little guy, we're talking about experimental research. Okay. Now, if you remember when we talked about that before, experimental research is when the researcher does what? Experiments. The researcher does something. He or she experiments. Okay, they have direct control over it. It's an inductive approach to research where they experiment. And now when you have experiments, we want to think about them in 2 ways. The first way is if we just have 2 groups. Okay? And the other way we want to think about it is if we have greater than 2 groups. So 2 groups would be, I have my control group, and I have my experimental group who's getting the intervention. One group is getting individual work, one group is getting group work done. That's 2 groups. 3 groups would be, or more than 2 groups. Group A is getting this, group B is getting this, group C is getting this, group D is getting this, and I'm looking at how what I do affects multiple groups. I might have a control group, I might have a male group, I might have a female group, and I might have a combined group or something like that. Okay, I might have the different types of leadership that you're talking about. I know there's more than just 2, so there might be other groups. Okay. So what's that?
Are you writing on the board?
I am.
Can you turn me so I can see?
Sorry. I'm not used to this. Can you see now?
No.
Can you see now?
Oh, it's on the screen?
Yeah, it's on the screen. So you're not gonna be able to see I don't think Google Chat will screen share. Sorry, but I'm recording this and it'll be on the website in like 30 minutes.
Okay.
Alright, so chill out. Alright. You're on vacation.
I'm a visual learner, sorry.
Alright, it's okay. That's why I'm recording it. Okay. So when you have 2 groups, the statistical test that's going to compare the groups is called a t-test. That's the test that they will do. Okay? Now you will either hear something called an independent t-test or a paired t-test. You don't need to know that. We don't need to focus on that right now. Okay? What you're going to see is the word t-test. And if you see it, your mind should go, there are 2 groups. If there were 3 groups, they used the wrong analysis. Okay? You are going to see symbols in here like T, P, and alpha. Those are the symbols that are going to appear. You don't need to know what they mean or anything like that. You just need to know that if you see a t-test and you see those symbols, I'm going to now predict what's going to happen. So this is where you become a powerful reader. You read the abstract and it says a t-test was conducted, and then, or you see T equals something, and you go, okay, I'm about to read about 2 groups being compared. Predicted, right? And then you go and you find it out and you feel really good about yourself because you were able to predict it. Okay. You guys have any questions about that? Is that alright? Okay, so how are you going to write about it? When you write, I don't want you to put any symbols. Okay, you're also in here, by the way, you're going to see means and you're going to see standard deviations as well. That's other symbols that are going to show up. Okay? You don't have to put any of these symbols because everybody knows you didn't have statistics when you wrote this paper. Okay? So when you write it, and everyone knows you're just regurgitating whatever you got there. But what it means, okay, you're going to be writing something like this, not word for word, but something like this. You're going to be saying a statistically significant difference between groups, okay, blah and blah did or did not exist. Okay? And the T's and the P's and all that garbage describe that. But all you have to say is if it existed or it didn't exist. So when you read the results, they're going to give you a bunch of garbage, and then they're going to say, so there really wasn't a significant difference, and that's all you have to say. You guys hopefully won't be reading a lot of this stuff because you're reading it more qualitative.
A lot of times it's in the narrative anyway. I mean,
The
a lot of
indicator?
times like the crazy nonsense is usually like explained later.
Okay.
Or the narrative, which is helpful.
So here's the main reason why, literally, the best feedback I got last semester was, in knowing this, you can read just the abstract and you can learn a lot. Because in the abstract, they're just going to give you the statistics. So if you know what that stuff means, man, you can like start thinking about t-tests over here, other things over here. Okay? So this, if you have greater than 2 groups, okay, you're going to be doing something called an ANOVA. Hence, this over here. And if you see the word ANOVA, which you're going to see a lot, this is the most common statistical test that exists. You're going to see symbols, instead of T, you're going to see F. And you're going to see P, and you're going to see alpha, and you're going to see mean, and you're going to see standard deviation. Is that clear, guys? Okay, you're going to see F instead. I don't know why, but F means the same thing as T if we have more than 2 groups. All right, now what do you think is going to be a complicated thing about having more than 2 groups if we're doing something? So I have group A, B, and C, and I do the same thing. One group gets nothing, and group B and C get something. What's complicated about that? How to compare, exactly. How do I know? The statistics are going to tell me one thing. So they're going to say this, okay? They're going to say, this whole thing, I'm just going to rewrite it, why not? A statistically significant difference, and watch kind of how this changes. A statistically significant difference between groups did or did not exist. Okay, what is unclear about that? That's what the results tell me.
Which groups and which differences?
Which groups and which differences, right? So A, B, and C, the results tell me, boom, difference between groups. I'm like, sweet, it did something. I don't know where, I don't know if it was between A and D, or A and C, or B and C. I don't know where the difference lies. It might have been between B and C and A and B, or B and C and A and C. You need to be able to outline exactly where. So that's, when you read your abstract and you see ANOVA, your mind goes 3 groups. And if the mind goes 3 groups, they have to do what's called, okay, follow-up tests. Follow-up tests required. And what do you think the follow-up tests do? They identify where the difference is. So this is beyond what you guys need to know, but essentially what they're going to do is they're going to do a t-test between each of the groups. So they're going to use the t-test strategy on A and B versus A and C versus B and C, and then we're going to see if it exists. So if you guys are reading this and you go, sweet, ANOVA, boom, I know what's going on, and then suddenly you see T, don't think that that's a weakness. Maybe the t-test is the follow-up test that they're doing between groups. That's what's going on. So getting over the experimental research hurdle can be a little challenging, and this is how you're going to write about it. Okay, if you guys get what this means. I still don't even feel like I understand what this stuff means. Okay, so don't write about it. If you don't know what it means, you don't need to include those numbers. Yeah.
If we have to do this for ours, and you're like, I have 4, I was thinking, do you have a special techie program that can help us with that?
Oh yeah, for sure. Oh, how to do it?
Yeah.
Oh, so okay, I'll tell you about mine. I did t-test, I did t-correlation and ANOVA on all mine, and I literally Googled, because there's this thing called SPSS that costs like $500 that you can buy that'll do it all for you. It sucks. Has anyone dealt with SPSS? Right, it's stupid, right? Also, Excel sucks with this. It's too hard. Google Docs are pretty easy actually. There's a whole Google Docs template that will do all this stuff for you, right? If you go spreadsheet, insert, script, and you look for t-test calculator, it'll do it. It'll give you a column to enter. But the easiest thing I did is I just went online t-test calculators. And it literally asked me for the mean of group A, the standard deviation of group A, the mean of group B, the standard deviation of group B, and the sample size, and boom, it told me if there was a difference or not statistically. It took me like 3 seconds, so I'll show you that one.
So my only question with that, having been a science major, is that there's like multiple kinds of standard deviations, and do these things specify which kind of standard deviations they take?
Yeah, they do.
Because there's different ways to do things. So will you know upfront what kind of t-test variables are taken?
Yeah, you will. That's beyond my knowledge of these tests, though. They just kind of do it. I figure it's the standards. I don't know the differences, but they will take that into account. And no one who reads your thing is going to focus on the type of standard deviation either. So I don't think that's gonna change the statistics that much. It might. I mean, you know more about this than me, so ignore I said that. I didn't mean to jump on your content domain there. All right. So the next kind is correlation. 1 L or 2 L's? And 2 R's? I don't know, whatever. Correlation. Okay. So what is the statistic? In experimental research, we had the t-test and we had ANOVA, primarily. Now, I don't want to do this, but I'm just going to back up for a second. I just want to say something. You're going to see 2 variations of it. I don't want you to be uninformed readers. That's like really important for me, okay? So you're going to see 2 variations of ANOVA. You're going to see something called MANOVA, and you're going to see something called ANCOVA. It's really ridiculous, right? The whole thing. All right. So why don't I tell you what ANOVA stands for? It stands for Analysis of Variance. So we're analyzing how everybody varies. Okay. MANOVA stands for something. Man, it involves only men, right? And so it's like multiple analyses of variance or something like that. And ANCOVA stands for Analysis of Covariance. Okay, so I'm just going to tell you what the differences are, just so you're smarter people with it. If I do something to each group, what does the group take when it's over to tell me if there was a difference? A test. You guys took the test on using numbers, right? If there is more than one test, that's MANOVA. So if they use 2 or 3 different post-tests, that's called a MANOVA. So multiple dependent variables. Okay, remember when I talked about the handicap thing? So let's say I have groups who are different on the pre-test, and I want to handicap them. I'm going to do ANCOVA, and the handicap is called the covariate. And what it does is it changes the stats for me without me doing anything, and spits out numbers. So I tell the machine up front what the pre-test difference was, and the ANCOVA calculation takes that into account on the final answer. So if you're reading something and you see ANCOVA, you say, wow, they had more than 2 groups, and the groups were not equal beforehand. If it's MANOVA, you said they had equal groups, but they were measured on multiple different variables. Or you can see MANCOVA. Multiple variables measured with non-similarity between groups initially. Okay, so I'm telling you, someone's got to tell you this stuff, right? Like, and so it's enough of that talk. All right, correlation is really easy. A lot of you guys might do correlation if you do research, if you choose to do quantitative research. What you're going to see if you do correlation is you're going to see something called the correlation coefficient. 2 F's or 1 F?
2 F's.
2 F's. Okay, that's true. Correlation coefficient. Okay, and the correlation coefficient is a little r. That's what you'll see. Correlation coefficient is a little r, and there's an actual name you might see. Okay, it's called the Pearson product moment correlation coefficient. But as long as you see the word correlation coefficient, that's all you gotta remember. Okay, I'm not gonna have you write that. Now, what are the two values a correlation coefficient can be? Any ideas?
1 and 0.
Okay, close. It could be between 1 and 0, but
But you can also positive and negative.
positive and negative correlation coefficients, right? So correlation coefficients can be positive or negative. What that means is as one thing goes up, the other one goes down. That's a negative correlation, okay? As one thing goes up, the other goes up. That's a positive correlation. Both are, it depends on what you're looking at. So negative doesn't mean bad in this case, okay? What we want to look at, though, is, do you guys remember from math what that means?
Absolute value.
Absolute value, right? So absolute value is all positive numbers. So if the absolute value of r, okay, is between 0.5 and 1.0, this is it's a pretty strong correlation. You're never going to have exactly 1. That's a perfect correlation. That means that everything that happens at A happens at B. Done, okay? Or vice versa. So if you're looking at the literature, here's a great place in terms of this, wrong statistical analysis. They say that R was like 0.2. And then in the results they say a significant correlation exists between the two. Hold on, R was 0.2, right? R needs to be 0.5 and 0.1 for there to be a significant correlation between two groups. So you are not going to write R, okay? You're going to write something like this. A strong correlation between, let's just call it A and B exists. And I'm sorry, here you want to say if it's positive or negative. So you could say a strong positive correlation exists between SAT scores and first-year college GPA. Okay? A strong but negative relationship, and you can actually use the word relationship with correlation, exists between mentorship and teenage pregnancy, right?
That's right.
Yeah. Okay, let's shut up. But there's a big thing here. I don't know if you guys know what this means, but that's huge. And this is why it's hella easy to do. Because, sorry about my California language, alright? You are, or Northern California language, sorry. You are not at all you are not the one doing it here, okay? You can correlate your experimental results. But usually what you're doing is you're looking at pre-existing data sets. So I'm going and I'm looking at I'm looking at all Montessori schools, and then I'm looking at performance on the GRE. And I'm trying to correlate, attendance in years attending a certain type of educational system to some sort of outcome measure. And again, Google, correlation coefficient calculators, or go into Google Docs and look for the spreadsheet that's got that template. And you literally just add the raw scores of one group and the raw scores of the other, and it just does it for you. It gives you the R. Super simple. Does that make sense, guys? Okay, so again, you're not going to write up numbers. The last one is the one where you are going to include numbers sometimes. Yeah. And this is the easiest to do, and this is what I really think is going to be really powerful in the 21st century when surveys can be administered online. Okay, so survey data, you can get some really powerful stuff here. I mean, Shiloh was freaking Facebook. I mean, that's awesome, right? You can get like all kinds of stuff. So, survey data, all you're going to see, the only statistics you're going to see percentages. Okay? You're going to see means. And you're usually going to see like frequencies. How frequently occurred. And that sometimes will be reported as a percentage, but not always. Okay? Sometimes a fraction. So this is really all you're going to see. Is these kind of things. So you're not doing anything. You're just giving a survey and you're saying 7% of these people said this, and 6% of these people said this, and 9% of these people did that. And the frequency of people who did this was this. And the average scores were that. But you're not comparing anything, you're just reporting back, you're describing things. So oftentimes, this kind of research is called descriptive. You're just describing what's happened. So, X% of men, and Y% of, obviously, blank, demonstrated blah. Okay? So in this one here, you are allowed to write numbers. I mean, come on. I mean, you're allowed to write numbers. If you want to write about t-tests, you want to learn about what that is, go ahead and write it. I'm giving you the okay, and I know that your advisor will give you the okay to not write about numbers unless it's survey research. Okay? So, yeah. You have a question?
I had a question.
So that's how your head goes.
So if we are doing a t-test in our city, we don't have to write out the numbers, so we just have to put like a chart?
Oh, okay. Great question. We're talking about the literature here.
Oh,
So we're talking about reviewing other people's literature.
okay.
If you do a t-test, we will do a specific kind of t-test chart. Okay, APA actually will show you how to do that chart. You'll put in the T's and the P's. You don't have to describe what those mean or anything until you get to the results section, but your chart will have all that outline. Okay? So that was like educational statistics in a nutshell. You could go watch the Khan Academy or something to get more information on that if you want. Does anyone have any questions? Was that helpful? Get that info? Okay. So why don't we take a 10-minute break right now, and then we're going to do one little activity and we'll be done.
So we're taking a 10-minute break.
We're taking a 10-minute break. Overachiever.
What?